circle here. We've usually got our three common angles. What sum and difference formulas are going to help me do? Let me put them in each quadrant real quick. Okay, what sum and difference angles help me do is they help me find the exact values for these. Okay, and so I'm just going to do it in terms of degrees. This would be 15 degrees. Basically, you're 15 degrees in from each quadrant. This one's going to be 75 degrees. And if I put these in there, okay, I could just keep going around here. This one's like 345 degrees because it's 15 degrees from 360. This one down here would be like 285 degrees. And so what I can do, instead of using my calculator to estimate those values for the sine and cosine, is I can find the exact values. Okay, so let's look at an example here, and let me show you how to use the sum and difference formulas. Okay, I'm gonna try to kind of ease you into it, because a lot of people, they really struggle with these, and it's not the trig, it's all the other stuff in there that's difficult. All right, let's try this one, the cosine of 75 degrees. And what we're going to do is we're going to use a sum and difference formula to find that exact value. Okay, so not some decimal approximation. Now, get your calculator ready because we're going to check it with a calculator. Okay, but we're going to find the exact value using a sum or a difference formula. Now, this is what I want you to do. Have your unit circle out. I know you like juggling your two formula sheets with your unit circle, your calculator, and all this stuff. All right, on your unit circle, you have to make a decision here. Do y'all want to find two angles that add up to 75 or subtract to give you 75? Add. And most of the time, it's easier to add numbers than it is subtract it, especially mentally. Okay, so we've made the decision that we're going to add two numbers. Now, obviously, there it's cosine, right? So what I'm going to use is I'm going to use that formula, the cosine of a plus b. Okay, so let me copy down that formula. Cosine of a plus b equals cosine a cosine b minus sine a. Okay, now here comes the actual part where you have to think. Okay, because most of this is just plugging stuff in. Again, we're looking for two angles on our unit circle because we know those sine and cosine values that add up to be 75 degrees. Okay, really there's only two of them that would work right there. What are they? Yeah, 30 and 45. Okay, now since you're adding, of course, the order wouldn't matter. Okay, so y'all want to put the 30 first? All right, so for A, we're going to use 30 degrees, and for B, we're going to use 45 degrees. Okay, because 30 and 45 will give me 75. So now, this is the way I do it. Instead of like rewriting the whole formula with 30 and 45 in it, I just write the angles above it. So the A is 35 and the B is 45. I'm sorry, I said 35, didn't I? 30 and 45. Okay. No, it doesn't. Right, as long as what? One is 30 and one is 45. So we could have said 45 and 30. Okay. Now, let's plug them in. Or let's look on our unit circle here and figure out, well, what's the cosine of 30 degrees? Square root of 3 over 2. Okay, and now notice what operation's happening right there? Multiplying, okay? So I'm putting them in parentheses to show that I'm going to be multiplying. Now, what's the cosine of 45? All right, so I'm going to be multiplying those in just a second. I got minus. Now, sine of 30 would be a half. All right, and then the sine of 45 is square root of 2 over 2. All right, well, let's talk about that. We've got what? Multiplication and subtraction. What are we supposed to do first? Multiply. Okay, so let's multiply first. Now, here's where people kind of like lose it because it's not the trig, it's all like the algebra that has to happen in the math, happen to add or subtract and multiply all this. So we're going to multiply this, and people get lost right there because they forget how to multiply radicals. So if I say square root of 3 times square root of 2, can I actually multiply that? Is that actually square root of 6? Yes, it is. Okay, it's square root of 6. What's something I can't do with like square root of 3 and square root of 2? Right, you can't add them. So you couldn't say square root of 3 plus square root of 2 is square root of 5. Okay, but it's certainly okay to say square root of 3 times square root of 2 is square root of 6. Now, here's the other thing that people mess up is they leave this as a 2. Well, it's 4. What are they thinking, you think, when they don't change it? Like adding, right? Because when you add, you don't change the denominator. Okay? But that's where all the people kind of screw up, is the multiplying and the subtraction here. Now, I'm going to bring down my minus sign. All right, 1 times the square root of 2 would be square root of 2. And then 2 times 2 again is over 4. Now, let me just tell you a huge secret. On all of these, especially with sine and cosine, the sum and difference formulas, y'all, you get the same numbers over and over and over. And it's these three numbers: square root of 6, square root of 2, and 4. It's just a matter of what signs are in between them, okay? Whether they're positive or negative. So let's do this. All right, it's always going to work out where these are 4, okay? And that's pretty nice. Why is that kind of nice there? Because we don't have to get what? Common denominator. It's already there. Okay, so the only thing we're going to do, can we say square root of 6 minus square root of 2 is square root of 4? No. But we can write it over one common denominator then, right? So I'm going to write like that. Okay, and that's the exact value there for the cosine of 75 degrees. Okay, so y'all, I wouldn't write these down here. The other variations that you get would be like square root of 6 plus square root of 2 over 4, or you could get negative square root of 6 plus square root of 2 over 4. Yeah, it's always going to be 4, and the numerators are always going to be square root of 6 and square root of 2. It's just different versions of, sometimes they're positive, sometimes they're negative. Okay, the other version would be if both square root of 6 and square root of 2 were negative. Okay, every answer is one of those 4. Right. Okay, and actually what I do in dual enrollment is I teach them to memorize them. Now, the reason why we can memorize them there is we don't have to show work on tests. Okay, but y'all do. Sorry. Okay. Now, so I want you to show the work, and you'll probably start memorizing them as you do more of them. Now, let's do this. What we can do, and I haven't really done this in the past with my students, is check with a calculator here. Okay. So the cosine of 75 degrees, whatever the calculator says, should be equivalent to this expression right there. Okay, so let's punch in. Be sure you're in degrees, right? Because we're saying cosine of 75 degrees. Right, I checked it earlier, and I'm in degrees here. So cosine of 75 degrees is like 0.2588. Okay, now this square root of 6 minus square root of 2 over 4 should be the same thing. Okay, so let's punch all that in. Now, you kind of got to get a little complicated with your fraction here a little bit. Like that. So here we go, square root of 6. I'm going to jump minus square root of 2. And be sure you hit minus right there instead of the negative sign. Okay. Over 4. Anybody want to bet that it's the same thing? I was going to try to win some money. All right. Y'all see how we can check our answers there now? Okay. So I'm probably not going to bother with checking many more with you, but certainly, when you get on a test, use this to check. Yes. No, it doesn't. Okay. So I think what you're going to have to do, Miranda, the way you punch it in, you do this. Okay. Put it in parentheses, and then say divided by 4. Okay. Now, let's look at another one. All right, let's try this one. Let's do a 15 with you. All right, let's try this one. Okay, and let's do a sine. Let's do the sine of 15 degrees. Now, this actually comes out to be the same thing as what the cosine of 75 is. Okay, so we're going to get the same answer we got as the last one, but let's just focus more on the process than the product. Okay, now here again, we're trying to get 15 degrees, and what we're trying to do is we're trying to pick two angles off our unit circle that are going to add to 15 or subtract to 15. Now, clearly with 15 being so small, we're probably going to have to subtract. The only way you could do it with addition is if you used negative angles, okay? But it's probably definitely easier to subtract here. So out of my formulas here, which one do I need now? Right, okay. All right, so let me write down the formula, and y'all can probably go ahead and figure out what the two angles are going to be. All right, so this is sine A times cosine B minus cosine A times sine B. All right, y'all check me. Did I copy that down right? Sine A cosine B minus cosine A sine B. Okay, so what two angles here we call A and B that'll subtract to give me 15 degrees? Yeah, 45 and 30. Okay, that's really the only combination. Okay, 45 minus 30 there would give me that 15. So for all the A angles, we're going to put in 45. And for the B angles, we're going to put 30. Right? Now, let's look on our unit circle and get off this. So what's the sine of 45? Square root of 2 over 2. Okay. The cosine of 30 is square root of 3 over 2. All right. Cosine of 45 would be square root of 2 over 2. Now, I'm just making sure. Are y'all seeing where these values are coming from? Okay. Obviously off the unit circle. Okay. So sine of 30, what's that? Square root of 1/2. I was going to say square root of 2 over 2. That's not right. All right, now let's multiply this out. All right, so you multiply, it's really the same thing as the last one. What's that going to give me the first two here that you multiply? Square root of 6 over 4. And then square root of 2 over 4. Now you're always going to get 4 as a denominator there. So it's going to work out really nice that you can just write it as one fraction. Okay, so that's the exact value here as the sine of 15 degrees. Okay, yes? Nuh-uh. Because when you subtract 30 minus 45, that would be the sine of negative 15. Right, because you're subtracting. See, if it was a sum, the order wouldn't matter because it doesn't matter the order that I add to numbers, but subtracting would. So if you switched them, like this one being 30 and this one being 45, that would give you the sine of negative 15 degrees. Okay. Yeah, question. All right, well, that's what we're going to talk about in just a second. Okay, so you want to look at a radian one? All right, let's do the cosine of 23 pi over 12. Okay, so clearly there we're in radians. All right, now here's one option. You look through your angles and you try to find two angles in radians, of course, that add up to be 23 pi over 12. Now, the radian measures on our unit circle are all in fractions, aren't they? So they're really, really hard to add. So what you have to do is think of them all in terms of 12, as twelfths, okay? So for instance, let me tell you which two they're going to be. I think it's going to be 5 pi over 3 and pi over 4. Okay, how could I write 5 pi over 3 in terms of 12s? What would that be? Yeah. Okay, and the other one I said was what, pi over 4? And so obviously I'm using a sum. Okay, what was that one? 3 pi. All right, y'all see how those would work? So my two angles that would add up to be 23 pi over 12 was 5 pi over 3 and pi over 4. Now, that's kind of complicated because you got to get the common denominator. So anybody got any other suggestions on making this easier? Y'all figure it out. Yeah. So you'd have to think of all your angles on your unit circle in 12ths. What's an easier way? Do what now? Well, yeah, you could do that. All right. Now, when it was like this, I mean, y'all tell me 45 and 30. Yeah, there you go. So we could just change it to degrees, and if it's in degrees, you can like come up with the angles very quickly, can't you? Okay. So can we change 23 pi over 12 in degrees? I hope so. Okay. So let's change it to degrees, and that makes it much easier to deal with. Okay, so that's the solution around the radians, is just to change them to degrees. So let's go over here. Let's do 23 pi over 12 radians and switch it to degrees now. Okay, so what do we know? There's what? Pi radians and 180 degrees. Okay, so pi radians cancel. And so now all we have to do is 23 twelfths times 180. Okay, so 23 over 12. Times 180. Okay, so it's 345. So now we're just going to write it as the cosine of 345 degrees. Okay, now, do you guys want to add or subtract to get 345? Add. Okay, so there's lots of combinations to give you 345. One that's really easy to me would be 345. Okay, yes, it doesn't matter. You do whichever one you want to. Okay, now since 345 is so big, I think adding would be much, much easier. Okay, so it's either way, add or subtract. So y'all come up, I said 345. What would be two other angles? All right, but you got to use them off the unit circle. 15 is not on my unit circle. Well, 50 is not on my unit circle. Look on your unit circle. Find me two more. All right, 315 and 30. Yeah, 315 and 30 will give you 345. Okay, that would work. All right, 225 and 120. Yeah, so y'all see there's like lots of combinations there. Okay, there wasn't really a lot of combinations with 15 or 75, but this one you can get a lot. All right, so ultimately, which ones do y'all want to use? Yes. Okay, and I'll show you in just a minute, like what if I use a different combination than you, how our answers might look different, but they're going to be the same. Okay, y'all want to just use 345 here? Okay, all right, now we're using a sum, right? So we're going to use this one. Okay, now y'all help me out, call this out so I don't have to like look over there. This is what cosine. All right, sine A, sine B, is it minus though? Okay, it's minus. So it is kind of tricky that that's plus, but yet over here in the formula is minus. All right, now we said that we would use 300 degrees and 45. Could I swap that order? Yeah, okay. All right, let's do 300 for A, 45 for B. Now we're fixing to look all these up on the unit circle. Now, the values that you're going to get, you're going to get square root of 6, you're going to get square root of 2, and it's going to be over 4. Maybe not in that certain order with positive and negative signs. I don't know which one's going to be positive, which one's going to be negative. Now, let's throw it in here. Cosine of 300 degrees is half. Okay, cosine of 45 is square root of 2 over 2. All right, sine of 30 is negative square root of 3 over 2. And then sine of 45 is square root of 2 over 2. Okay, now y'all help me multiply this out for me. Multiply that for me. All right. Minus negative square root of 6 over 4. Now that minus a negative, it would just, what, add? Yeah, so it would be square root of 2 plus square root of 6 over 4. Okay, now Takira, you ask about, maybe if you don't use the same two combinations as somebody else, you might get this instead. Now, would that be the same thing? Same thing. All right. So we see what to do with radians. Let's check this one since it was in radians. Now, if you were going to check the 23 pi over 12, you'd have to switch your calculator to radians. So let's just keep it in degrees. Let's do cosine of 345. Okay. Let's Okay, so 0.9659. Now, let's check that and see if it's the same thing. Okay, so we got square root of 2 plus square root of 6 over 4. All right, got it right then, right? All right. Now, because I punched in 345, I didn't have to switch to radians. Now, if we punched in 23 pi over 12, we'd have to switch to radian mode on my calculator. Okay. Well, what do you mean? How would we get it otherwise? All right. Well, what's the problem with the answer in the calculator? It's decimals. Okay. And that's exact. Okay. Now, if we was finding decimals, we wouldn't be having this lesson. I think we'd be trucking on. All right. Now let me do like one more with you, and then I'm gonna flash my textbook up so you guys can get a picture real quick if you want to. Yeah, go ahead. Now, let me throw this one at you. Let me think of one real quick. That's what I'm gonna do here. All right, let's try this one. Let's do the sine of negative 165 degrees. All right, it's negative. Now you could add, and you could add two negative angles. Okay, but let's just use something that we already know. What did we say about negative angles on Friday that we could do? All right, you could do that. You could find a coterminal angle by adding 360, and that would work fine. Okay, but let's use something that I don't really have to do any thinking about, hopefully. Sine was even or odd? Odd. So sine of negative 165 would be the same thing as what the negative sine of 165. Okay, so let's do this. let's find the sine of 165 and then make it negative. Okay. Now, you could certainly do what you said there. You could add 360 and find a coterminal angle. Okay. But I could do this a little bit quicker, couldn't I? All right. Now, do y'all want to use a sum or a difference to get to 165? Sum. All right. And I think most of the time, unless it's 15 degrees or pi over 12, you're probably going to use a sum. Okay. So sine of a plus b equals, this is what, sine a cosine b plus sine b. I'm getting it all wrong, aren't I? I got to look. I tried to memorize it, but never mind. So sine a cosine b plus a. Is that right? No, I mean, you could like switch these because you're multiplying. Okay. But I mean, just you got the formulas. You don't have to memorize them. Okay. So don't stress over that part. Now, so what's two angles here I can add together to get 165? All right, 135 and 30. All right. Yeah, that's what I was thinking about. 145 or yeah, 120 and 45. Okay. So it really doesn't matter as long as they add up to 165. Okay. Now let's put them in over here. So we got 135, 30, 135, and 30. Okay. All right. So now what's the sine of 135? Square root of 2 over 2. All right. Cosine of 30 square root of 3 over 2. All right. Cosine of 135 is, yeah, negative square root of 2 over 2. All right. Sine of 30, yeah, that's a half. Okay, now let's multiply this out. This is going to give me square root of 6 over 4. Yeah, I just want to go ahead and just figure out your signs. You got a plus and you got a negative, so that's just going to end up being negative or minus square root of 2 over 4. And now let's just write it all over 4. So square root of 6 minus square root of 2 over 4. Now, recall what this was. This was the sine of 165. Now, the problem was the sine of negative 165, which we figured out all we have to do is just make that negative. Okay. Now, when we make it negative, do we just make what, the first term negative or all of, right? So you distribute the negative to both numerators there. Okay. So really my answer is going to be negative square root of 6 plus square root of 2 over 4. Okay. Now let's see if you guys can think, what if we did kind of like what Taiwan said and we didn't use 135 and 30? What might happen if you use two different angles is you possibly could get this answer. Now, would that be equivalent there? Yeah, same thing. Okay. So sometimes when you check your answers, the textbook may have this as the answer in the answer key, and you got this, but it's the same thing. Okay. So you have to look at that. Now let's look at that in the textbook. Let me bring that up. Y'all look at it. It's on page 442. And we'll let you guys especially get a picture of mine so you can get the answers in them and kind of check them. All right. Y'all want to come up here and all right, you've got number 5. And basically what I'm giving you is but just the ones with sine and cosine. Okay, we'll talk about tangent tomorrow. That gets pretty nasty. Yeah, they are. I'm gonna lie to you. Tangent is, yeah. All right, they're written over there for you. Page 442, number 5, 14 through 17, and then 19. If you want to like take your picture of them real quick, you can do that. And by the way, on number 5, probably the way you're going to write your answer, instead of they like make the whole thing negative, I would write it like that. Okay. Yeah. So, I mean, you're going to use the unit circle quite a bit on this test. Okay. Right. Oh, and by the way, I found a video on YouTube last night. This lady, she does like a finger trick on remembering the ordered pairs in the first quadrant. It's pretty cool. Okay. She like, she names, like if you put your left hand like this in the first quadrant, this is 0, this one's 30, this one's 60. Wait a minute, let me think about that again. 0, 30, 45, 60, 90. Gives you your 5 angles. And like if you do the 45, you fold in this one, and it's the square root of 2 over 2 is the sine. The cosine is the bottom 2 fingers over 2. Watch the video. It's really neat. I mean, it's the first time I've ever seen anything like that. I had to watch it twice before I got it because I'm a little like, especially like with hand knuckle, I'm like a little slow. Get it. All right, here's the other ones. All right, y'all take a picture if you want to take a picture. Do one of my textbooks. You'll have the answers, okay? And I'm taping this too, so y'all can pull it off the video that I emailed you to.